So when we look at our planet, you might wonder how is the moon not just floating away from Earth instead of just spinning around it? You probably didn't ask it actually, but who cares? Anyways, first to be able to answer that, we'll need to have to see the term or more of the idea of Roche limit. So the Roche limit, also called the Roche radius, is the distance from a celestial body within which a second celestial body, held together only by its own force of gravity, which will disintegrate because the first body's tidal forces exceed the second body's self-gravitation. Wait. Hold up. So, tidal force? Self-gravitation? What are all those words? So, we will be going through them one by one, so just wait for it, okay? Now, every celestial body has this thing called self-gravitation, which is a gravitational force that is applied by a system or one or more celestial bodies onto itself. At an adequate mass, this allows the system to hold itself together. Also, the strength of self-gravity differs depending on the size of the object and the distribution of its mass. An example of this would be something like Saturn's ring or Earth's moon. Now, tidal force, or the gravitational effect that stretches a body along the line towards and also away from the center of mass of another body due to spatial variations in strength in the gravitational field from the other body. So back to where I was. So inside the Roche limit, the orbiting material will disperse and form rings, which would be the case of Saturn and its rings. And then if the orbiting material is outside the limit, it tends to somehow merge, and the Roche radius depends on the radius of the first body and on the ratio of the body's densities. Roche limit typically applies to satellite disintegration due to tidal forces which induces by its primary the body around which it orbits. The parts of the satellite that are closer to the primary will be more strongly attracted by the gravity from the primary than parts that are farther away. This imbalanced state effectively pulls the near and far parts of the satellite apart from each other, and if the disparity, which combined with any centrifugal effects due to the object's spin, if it's larger than the force of gravity holding the satellite together, it can basically pull the satellite apart. Some real satellites, both natural and artificial, can orbit within Roche limits because they are held together by forces within gravitation, like the moon or the satellites that we have for our internets. However, the objects that are resting on the surface of such a satellite would be lifted away by tidal forces. A weaker satellite, such as a comet, could be broken up when it passes within its Roche limit. So that answers the question of how does the moon stay around the Earth without drifting or being pulled